Welcome back to chemistry. Today we're continuing our series on periodic trends. Today we'll be talking about ionization energy. To start this off, we're going to do a quick recap. I said for any trend on the periodic table, there are two things you have to look at. You have to look at the Zeph, which is the positive pull from the protons. The more protons, the greater the pull force. So it increases on the periodic table as you go right, because as you go right on the periodic table, you gain protons. Each one has one more than the other. Okay? So we use the Zeph for determining the side-to-side trends, the pull from the protons. The second thing we're looking at is energy level. This determines the up and down trend. Well, what is the energy level? It's the distance from the nucleus. As you gain each energy level, the distance from the nucleus increases more and more and more. So kind of what we're really looking at is atomic radius. Atomic radius was our first trend. Remember, the atomic radius increases as you go left on the periodic table and down. Okay? Remember, up and down always trumps left and right when we're looking at any trends. Whoever's the most up, whoever's the most down will trump whoever's the most right or left, depending on how the trend goes. Okay? Last video you watched, you looked at electronegativity, the ability to attract electrons. We learned that, well, if you have a high proton count and low energy levels, thus a small radius, it's easier to attract these electrons. Kind of makes sense, right? High protons means you have this strong pull force to attract electrons. Low energy level or small radius means you're closer to the nucleus. The closer you are, the stronger it is. Okay? Well, electronegativity, the ability to attract electron, increases on the periodic table as you go up and to the right. And that brings us to today's stuff. Today, we're going to be talking about ionization energy. Okay? Now, what is ionization energy? Ionization energy is the energy, put my hand down, it's the energy required to pull off an electron. Okay? It's the energy required to pull off an electron. Last time with electronegativity, we were talking about the ability to attract electrons. Now we're talking about getting rid of an electron. Okay? And how much energy that takes to pluck off an electron from another atom. Now, you got to think about it. What two criteria do you think you need to be able to steal an electron from an atom? Well, protons hold on to these electrons, right? So we want less pull force from the protons, okay? Less pull force. So less pull force means it won't take that much energy. More pull force means it takes a lot of energy. So to pull off an electron, we need less pull force, which means less protons. Now, we're talking about lowering this energy here to make it easy to pull off electrons, right? That's what we're trying to do. We're trying to make it easy to pull off electrons. Well, if we want it easy, we need less pull force. That means less protons, right? Now, to make it easy to pull off electrons, we also need to be away from the nucleus, right? Because the closer you are to the nucleus, the harder it is to pull off electrons. So what do you think? Do we need to be close or far from the nucleus? We want to be far from the nucleus. That's the second thing. Far from the nucleus. Okay? So what does that mean to be far from the nucleus? That means we want a big atomic radius, or a bigger atomic radius. Okay? Now, let's look on the periodic table what gets us that. Well, I want to do all my trends. We're looking at a trend for lowering the energy required. This lowers the energy required to pull off an electron, right? So, I want all my trends to be increasing. Okay? More energy. increasing ionization energy. So I want you to just remembering one type of trend, increasing ionization energy, which means if this makes it easier over here, what would make it harder to pull off an electron? Well, that means more protons, more pull force. A smaller radius, since a bigger radius makes it easier, right? So to create the trend for ionization energy, if less protons, remember, to get less protons, we got to go this way on the periodic table, right? Because going this way gives us more protons. So if I want increasing ionization energy, takes more energy to pull off an electron, that means we need more protons. So for increasing, it's going to increase as you go to the right on the periodic table. Because as you go to the right, you get more and more protons. Therefore, it's going to make it harder and harder and harder to pull off these electrons. Okay? Now, let's look at the up and down. We just did the side to side. Side to side always looks at protons, right? Side to side always looks at protons. Up and down, what do we look at? The atomic radius, right? How far we are from the nucleus. Now, what's it going to make it harder, more energy to pull off an electron? Big radius, small radius, right? Well, if it's easy to pull off electrons when we have a big radius, it's going to be hard to pull off an electron when we have a small radius. So which direction on the periodic table gives us a small radius? Well, let's go back. The atomic radius gets bigger as you increase energy levels, right? Remember that? Every time you go down, you gain one more energy level and your radius just gets bigger and bigger and bigger and bigger. So we want a smaller radius. So to get smaller radiuses on the periodic table, you got to go up on the periodic table to give you small radiuses. And small radiuses is going to make it harder to pull off electrons because you're closer to the nucleus. Okay? So there goes our trend for ionization energy, increasing ionization energy. Okay? It gets harder as you go up on the periodic table because the radiuses are getting smaller, that you're closer to the nucleuses. And it gets harder as you go right on the periodic table because you have more and more protons, so you have more of that pull power. Now, one extra quick piece of information. Once you pull off an electron, the second electron is even harder to pull off. The third electron is even harder to pull off. And the fourth electron, almost impossible hard to pull off. Okay? They call these ionization energies, right? Your first ionization energy, I'm going to put it IE. Your first ionization energy is some sort of energy, but your second ionization energy is going to be even more than the first, because the more electrons you pull off, the harder and harder it gets. And we'll talk about why it gets harder on our next video. But just know, the first ionization energy takes some sort of energy to pull off an electron. The second, if you try to pull off a second electron, it's going to be even harder. And if you try to pull off a third ionization energy, it's going to be even harder. Okay? So when you're plucking off of these electrons, the atom doesn't like it, and it doesn't want to give up the next electron, so it makes it harder. Okay? Now let's do some examples here for ionization energy. So let me try to get the periodic table back in the picture here. Okay? Now, we know ionization, what's the trend for ionization energy? It increases as you go up and to the right, right? It increases as you go up and to the right. That's for increasing ionization energy. Okay? So that's all we got to use is this trend. This is the only thing we need to know. So if you're answering questions about ionization energy and they give you, okay, you have boron, carbon, and fluorine, right? Which one is the hardest to pull electrons off of? Well, let's look. It gets harder as you go up, see it's increasing, and it's harder as you go right. So If you look, they're both the same up. They're on the same energy level, so we got to look at right and left. So who's the most right? Fluorine is. So he would be the hardest to pull off an electron from. Okay? So who would be the easiest to pull off an electron from? Well, if it gets harder as you go right, so reverse this, go left. So who's the most left? Boron is the most left, so he would be the easiest, right? He would be easy to pull off. Hydrogen would be hard to pull off. I mean, not hydrogen, fluorine would be hard to pull off. Okay? Easy, hard, based on the trend. Let's do another example. Okay? Now let's look at oxygen compared to chlorine. Okay? Oxygen compared to chlorine. Now, let's look at them. Oxygen is the most up, but chlorine is the most right. So who wins here? Who's the hardest to pull off? We're going to look at hardest, or most energy to pull off an electron, right? Who's the hardest or takes the most energy to pull off an electron? Well, it increases as we go up, and it increases as we go right. So oxygen is the most up, but chlorine is the most right. Who wins here? Remember what I said? That up and down always trumps left and right. So in this case, the guy most up is going to be the hardest. So who's most up, oxygen or chlorine? Well, chlorine's here. Oxygen is most up. So oxygen will be the hardest to pull off an electron. Okay? So guys, all you have to do is follow these trends, and you should be able to predict what elements do what based off their trends. But remember, all my trends are for increasing, so if they talk about decreasing, just reverse these arrows. And that is ionization energy, guys. Have a great day.